Okay, let's see how you did. When will 3x equal 0? Well, you can just kind of look at that with common sense and say, well, x will have to be 0. If you really want to do the solving steps, you're still going to get x equal to 0. So there's our first answer that could make the whole polynomial equal 0. Our next mini equation is x plus 7. When will that equal 0? Well, obviously, when x is negative 7. And finally, our last piece, 2x minus 9. When will that equal 0? Got a little bit more solving to do on this one. We've got to add 9 to both sides. 2x equals 9. Divide both sides by 2. And x equals 9 halves, or if you like, 4 1/2. So we have three possibilities for values that we can put in for x to get the function to equal 0. I'm going to leave you with one last one, and I'm going to do it on a separate sheet of paper. H of x equals x squared minus 5x minus 6. H of x equals x squared minus 5x minus 6. Now what's different about this one is it's not in factored form. And so we can't identify these pieces that are being multiplied. But guess what? This is a trinomial that can be factored if you remember back to week 1. Let's get two pairs of parentheses ready. Let's get our x's here and here. Remember, this is the opposite of FOILing. You're thinking backwards to what binomial times what made this polynomial. So we ask ourselves what pair of numbers multiplies to make negative 6 and adds up to negative 5. Let's try, usually a 3 and 2 is a pretty good guess. 3 times 2, hang on a second, we're going to make this a plus 6. There we go, that's going to work better now. Okay, let's change this to plus 6. Alright, now we can use 3 times 2, but they have to add up to negative 5. So let's make them negative 3 times 2. And negative 3 plus 2 works to make the negative 5. So we know that we've got minus 3 and minus 2 for our two binomials. They'll multiply out to make this polynomial. Now we can find the zeros of the function. What makes this piece equal to 0 and what makes this piece equal to 0? Write out your two mini equations, solve them, and we get x equals 3 for this one, and x equals 2 for this one. So if you find you've got a trinomial that's not in factored form and you're asked to find the zeros, see if it can be factored and solve each piece set equal to 0.